students, we are going to see the next topic on observability, reflectivity, and transmittivity. So first we'll go through the term observability. So observability is out of total irradiation. We already know irradiation means the amount of radiation energy that incident on surface area per unit time. That is called irradiation. It means simply we can state uh, if you take a 1 meter cube area or 1 meter square surface area, unit surface area, and amount of radiation that is going to be fall on the surface with respect to a time per second, then it is called irradiation. So the amount of total irradiation and an amount of total radiation, this is sum, this is not SOM, this is sum. The sum part is reflected, some part SOME, here E is missing, sorry, SOME, some part is reflected and a part is absorbed and remaining part is transmitted across the surface or across the surface of medium. That is, the absorbed part is called as an absorptivity is defined as a fraction of total irradiation energy is absorbed by the surface. The absorptivity is defined as a fraction of total radiation absorbed by the surface. So absorptivity is a symbol called alpha, and alpha is defined as absorbed radiation with respect to total incident radiation. So total incident radiation is also called as irradiation. Absorbed radiation with respect to irradiation. So absorbed radiation has a symbol alpha G and incident radiation has a symbol G. So alpha G by G is, which is equal to absorptivity. So absorptivity is ranges from 0 to 1. So it is independent on surface temperature, or observability is independent of surface temperature, depends on temperature of source in which the irradiation is originated. It depends on temperature on a source in which irradiation is originated. For more understanding of observability, we will refer this diagram. So this is called irradiation. We have taken a unit surface area. Refer this figure 1.1. This surface area, we have a surface area, and it has an area will be equal to 1 meter square, and the irradiation, some part of the thermal radiation is incident on the surface. Some amount of irradiation G falling on the surface. When it fall on a surface, the surface will absorb a part of radiation. The surface will absorb a part of radiation, that is called alpha. Alpha is called absorptivity. Some part of incident radiation is absorbed by a body is called absorptivity, and some part of radiation is reflected from the surface. It is called radiation. Reflection. Some part of radiation is irradiation is reflected by a surface. It is called reflection through, and some part of radiation is transmitted through a surface or body. Some part of radiation is transmitted through a surface or body, that is called tau. So alpha is called observability, rho is called reflectivity, tau is called transmittivity. That is what we are going to see now. So next thing, reflectivity. So reflectivity is defined as a fraction of total incident radiation. The fraction of total incident radiation reflected from the surface. Some amount of radiation is going to be incident on a surface. From that incident surface, a part of incident radiation is going to be reflected. That is called reflectivity. So reflectivity is defined as reflected radiation with respect to incident radiation. Reflected radiation is known as rho G, and incident radiation is taken as G, which is equal to rho. Rho is a symbol for reflectivity. So reflectivity depends on direction of incident radiation as well as direction of reflection. Incident radiation angle and direction of reflection angle. It depends upon incident angle and surface or plate angle, surface or body angle. That is called reflection. So reflectivity are classified into actual or irregular radiation, diffuse radiation, and third one is called specular or mirror-like reflection. Specular or mirror-like reflection is called irregular radiation or irregular reflection or diffuse reflection or specular or mirror-like reflection. So irregular or actual radiation means a part of the incident radiation will incident on a surface. The irradiation will fall on a surface. A part of radiation will be reflected irregularly. It will have different. It will be reflected in different direction, and the wavelength will not be equal. And the angle between this reflection. If you observe this, the angle between the reflection, the angle between this different radiation will not be similar. It will be varying. Suppose if the angle here is 10 degree, here the angle will be 30, here the angle will be 45, here the angle will be 50. The reflection angle or reflection will not be uniform. You can simply say the reflection will not be uniform, then it is called irregular radiation. So next is called diffused radiation. In case of diffuse radiation, the reflection will be uniform. The reflection will be uniform means the angle between each and every radiation. Suppose here it is 30, here also it will be 30, here also it will be 30, 30, 30. So this is called the vertical central vertical line is called normal. Normal direction. This is called normal. Perpendicular line is called normal. For rough surface, for mostly rough surface, the diffused type reflection will be taking place. So next is called specular or mirror-like reflection. For very smooth surface, highly finished or polished surface will have specular or mirror-like reflection. This is called incident radiation. So whatever the angle of incident, if the angle of incident is taking place at 45 degree, suppose if the angle of incident radiation, the angle of irradiation is at 45 degree, then the reflection angle will also be 45 degree. So incident angle and reflection angle. If the incident angle of irradiation and the angle of reflection is same or equal, then we call it as a specular or reflect or a mirror-like reflection. It only takes place on smooth surface. So next is called transmittivity. Already you know transmittivity. It is defined as fraction of total incident radiation transmitted across a surface or body. Across the surface or body. The symbol is tau. So tau is equal to transmitted radiation by incident radiation. That is tau into G divided by G. G for irradiation. So now we can write an energy balance equation for all absorptivity, reflectivity and transmittivity. So irradiation. So irradiation is the total incident radiation. G is called irradiation or total incident radiation. The total incident radiation will be equal to observability. When a irradiation is incident on a surface, a part of radiation will be absorbed by the surface. That is called alpha G. A part of radiation will be reflected by the surface. That is called rho G. And a part of radiation will be transmitting across the surface. It's called tau into G. So when you bring this irradiation on right hand side, or divided by irradiation on both sides. When you divide it by G is called irradiation. When you divide the equation on both sides by G, then you will be getting 1 on left hand side will be equal to alpha G by G plus rho G by G plus tau G by G. So from the previous concept, alpha G by G is called as alpha, rho G by G is called rho, tau G by G is called tau, transmittivity which is equal to 1. So from this we are going to define variety of bodies. Suppose if the observability is 1 and emissive power, emissive power is 1, observability alpha is equal to 1 and emissive power is equal to 1, then we call it as black body or diffuse body. If reflectivity is equal to 1, then we call it as a white body. When the transmittivity is equal to 1, then we call it as transparent or diathermous body. When the transmittivity is equal to 0, when there is no transmittivity takes place on a surface, then we call it as opaque surface. That is tau is equal to 0. The property is not varying with respect to wavelength. The property are not varying with respect to wavelength is known as, or independent of wavelength is known as gray body. So next class we will see the black body detailedly.